Hello everyone, I am Harshavardhan Patil.
I'm Riya Kulkarni.
And I'm Rohan Hanze.
Our topic is double cover butt joint.
Let's get through it.
Coming towards the theory behind this model is that the double cover butt joint is a method of joining two steel plates end to end with the help of two cover plates, one on each side. This joint is commonly used in steel structures to ensuring the strong connection between the plates. The main purpose is to transfer the axial force from one plate to the another, minimizing the stress concentration and providing the uniform distribution of load.
Now let's see the significance of double cover butt joints. Double cover butt joints are really significant in construction and engineering, particularly for the structures like bridges, towers and buildings. They offer high strength and are ideal for the situations where large forces need to be transferred between the structural members. Their design assures that the connection is secure and reduces the risk of failure under load.
We have assumed these are the two main plates and these are two cover plates. We have assumed one bolt line per main plate. These ice cream sticks, we have assumed it as bolt shanks. Let's see the stress distribution. If we consider the bolts are stronger than the plates, then bearing action on plate will occur like this if the tension is applied axially. Then again one possibility is the shearing planes on these two horizontal lines. One more possibility is the tensile failure due to plates and block shear failure.
This was about single bolted double cover butt joint. Now moving on to our next model. For that, we have considered the gusset plate of 20 mm thickness, main plate of 12 mm thickness, and for the packaging, we have considered a plate of 8 mm thickness, and these two are the cover plates of 8 mm each. And the bolt diameter we have considered is 16 mm, so the gross diameter becomes 18 mm.
So let's do the calculations. First, we have considered the bolt diameter as 16 mm. So the minimum pitch should be 2.5 into the bolt diameter. It comes out to be 40 mm. So we have considered it as 40 mm. The maximum gauge distance should be 32 into thickness of thinner plate. So for our modeling purpose, we have considered it as 80 mm. And then sheared edges. The minimum edge distance should be 1.7 into cross diameter. So it comes out to be 38 mm. We have considered it as 40 mm. So let's consider the bolts are of 4.6 grade. That means the ultimate strength of bolt is 400 MPa. Consider the main plates are of Fe410. We have considered a double cover butt joint. That means the shearing planes are 2. Consider for safety the bolt is completely threaded. That means the NN becomes 2 and NS becomes 0. So if we consider A and B 0.78 pi by 4 into d square, we can calculate that, and ASB need not be calculated. And if we consider the reduction factors, the maximum length of joint should be less than 15d. Even if we consider the 4 bolt lines, it comes out to be less than 15d. Now the total grip length is 36 mm because it is 20 mm and 2 cover plates of 8 mm, and it's also less than 5d. So beta Lj and beta Lg are neglected. Now if we consider the packing plate is of 8 mm, that is greater than 6 mm. So we have to consider the beta pkg, that means reduction factor for packing plate.
Now for calculating design shear strength, we use the formula BDPB is equals to FUB into ANB into NM plus ASB into NS upon root 3 into gamma MB into beta LJ into beta LG into beta PKG. After putting all the values in the given formula, we get the final shear strength as 52.15 kN. Similarly, for calculating design bearing strength of bolt, we use the formula BDPB is equals to 2.5 into kb into nominal diameter of bolt into ultimate strength of plates into T upon gamma MB. Here T is the minimum of aggregate thickness of the cover plates and the thickness of thinner main plate. For this structure, T is equals to 12 mm. By putting all the values in the given formula, we get the final design bearing strength as 77.14 kilonewton.
Finally, the bolt value should be minimum of shearing strength and bearing strength. Here the shearing strength is minimum, so the bolt value is 52 kilonewton. If we assume that the factored load is 200 kilonewton, number of bolt should be factored load upon bolt value, that is 200 upon 52. It comes out to be 3.8. So let's consider we need 4 bolts per main plate. Here we have considered the 4 bolts in staggered bolting per main plate. That's why the total number of bolts is 8 in this model. Let's see the limitations of double cover butt joint. As you can see here, the aggregate thickness of cover plates is nearly equal to the main plates, which increases the requirement of material and also the cost. Second limitation is the requirement of space due to its heavy thickness, which may not be available in every structure. Also, the alignment of these two covers requires more precision, which increases the fabrication time. In conclusion, the double cover butt joint is a crucial member in design of steel structures. It utilizes safe and efficient load transfers between connected members. While our model provides a simple representation of how this double cover butt joint works. It is important to remember that the actual performance of this joint depends on precision in engineering and the strength of these materials. Therefore, this concept highlights that the importance of proper joint design in maintaining the structural integrity and safety of the structures.
Thank you everyone for watching.